Hey there, fellas. We're going to jump right into 8-6 here, going through the proportionality and the similar triangles. Okay, so we're going to use these things called the triangle proportionality theorems. Right, the basic one here is the first one that we'll tackle. Okay, so this one tells you that if you have a line that is parallel to one of the sides of a triangle, okay, so that means we've got two parallel lines. Basically, if you cut up a triangle with a parallel line to one of the sides, then it's going to divide those two sides proportionally. Right? So the parallel lines is the if portion. Right? So you have to have the parallel lines in order for this to work, this proportionality to work. But if that is the case, then that means that these little segments here are going to be divided up proportionally. So we can create these proportions. AD over DB is going to be equal to AE over EC. Okay, pretty simple, straightforward. I'll show you an example later on in this section. All right, the converse is also true. So the converse, what that means is that if you know that you have the correct proportions, then you can prove that the lines are parallel. Obviously, we're not going to be doing proofs with these. However, you're able to at least tell me that lines are parallel, which could be helpful in solving the problem. So if you already have, like, let's say, which one's longer? Let's say 4 and 3 and 8 and 6. Okay. Now, if you look at those, 4 over 3 equals 8 over 6. Is that true? Well, yes, it is true, because you cross multiply and you're going to get 24 equals 24, which is a true statement. Okay. So if those are true, right, if they are proportional to each other, then you can prove to me that these lines are parallel. Okay. So those two lines are parallel. So line DE is parallel to line BC. Okay, that's the if portion. That's the then portion. Just like that. Now, a couple other options for this. Okay, if you have three parallel lines here, so we're not doing triangles anymore. I mean, you could eventually create some triangles out of it, but not the general idea is not triangles. It's if you have three parallel lines, two transversals, right? The transversals are cutting those up. They're going to divide them proportionally. Okay, so as long as these lines are parallel, these arrows are very important. They have to be parallel to each other in order for this theorem to be used. If that's the case, then we could say that RS over ST is equal to XY over YZ. Pretty simple stuff there. And lastly, if you have a triangle with an angle bisector, it also will divide lengths into proportions. So first of all, you got to have an angle bisector, so that means that these two angles have to be the same. All right, that's very important that AD has to be an angle bisector. Okay, this has to be an angle bisector of angle BAC. Now, if that is an angle bisector, then we can write this proportion. Basically, the two sides of the long side that gets cut up, right, are proportional to the other two legs of the triangle. So BD over DC is going to be equal to the other two sides, AB over AC. Okay, that's just the last proportion you can make. So we've got three possible proportions that we can create with this this setup in this section. A couple examples. We're just going to be solving for x with each of these examples. So because we have these triangles and we've got the parallel lines for us already labeled, right, that means that we can set up our proportion. So we'll set up proportion 8 over x plus 2 equals 12 over 5 by using the triangle proportionality theorem. So you cross multiply, we're going to get 12x plus 24 equals 40. Okay, make sure you distribute this 12 when you do the multiplication. Okay, you got to distribute it. Solve for x, so 12x equals 16, and x equals 16 over 12, which reduces to 4/3. All done. Okay, this next one. Once again, we're going to solve for x. Once again, we already have our parallel lines labeled, so that means we can jump right into to setting up our proportion and solving them. So here's our proportion, 8 over 6 equals 10 over x. Make sure you have them all in the right order. Okay. Cross multiply. 8x equals 60. And divide by 8 to get x equals, should be 7.5. Yes. And last problem. Last one here, we've got our angle bisector, right? It shows that these two angles are congruent to each other, so that means that this is an angle bisector in this triangle, which means we can set up our proportion. So we'll go ahead and do that. 5 over 3, right? This side being cut up is equal to the lengths of the other two sides. Okay, make sure you keep, since the 5's on top, the 4x plus 1 has to be on top. That's very important. 4x plus 1 over 50. Okay, cross multiply. Make sure you do distribute. The 3 here has to go to both. So 12x plus 3 equals 45. And 12x equals 42. So x equals 3.5. And we're finished. Good luck, guys. See you in class.